Loser, hello classmates. My topic is all about factorial in randomized complete block design. So, RCbD factorial is a factorial experiment that employs blocking, and all the treatment combinations are present in one block. And this means that experimental unit in a block will be randomly distributed to the treatment combination in that block. Blocking assures that each treatment combination will have an equal chance to receive an experimental unit in that block. And each experimental unit in a block will have also equal chance to be assigned to any of the treatment combination. So RCbD factorial treatment sample, this is the data that we need to gather. Our factor A is our planting distance with A0 is 1 by 2 meter, E1 is 2 by 2 meter, E2 is 2 by 3 meter. With our factor B, which is our frequency on weeding frequency. B1 is our control, B2 is 2 times naman. With a treatment combination of E0 B1, E1 B1, E2 B1, E0 B2, E1 B2, and E2 B2. So this figure is our experimentally out in 3 by 2 factorial in Rcbd. So supposedly these are the data that we gathered on our number of leaves with our planting distance, weeding frequency, replication 1, replication 2, replication 3, and B total. With the replication total below and grand total in our grand mean. So supposedly all of the data, these are only example on how to solve the experiment. So CF, or our correlation factor, is equals to G squared, or our grand total, over N, which is our replication, then equals to 140.424 squared from our previous table, over N equals to 19,712.6 divide 18 is equals to 1095.12. Then second is our TSS. This figure we gathered on those from the previous tables. We squared all those figures, then we add with a total of 1,227.24 minus our CF, which is 1,095.12, is equivalent to 132.12. With our replication total from the previous table, 46.4 squared plus 46.6 squared and 47.4 squared minus our correlation factor over 8 times B, or our weeding frequency in our treatments, which is total of 6. Then we have 6,571.28 divide 6 minus our CF is 1,095.12. Then 1,095.21 minus 1,095.12 is equals to 0.09. This is our two-way table. Our AS is 46.2 squared plus 42.2 squared plus 52.02 squared minus CF over our frequency on weeding times our replication. 2 times 3 equals 6. with a total of 6,619.28 divide 6 minus 1,095.12, and we have 1,103.21 minus 1,095.12, and we had 8.09. So from our table shows where our data gathered, from our ASAs, which then our BACs from the previous table, is 47.1 and 93.3. So 47.1 squared plus 93.3 squared divide by our treatment and our replication is equals to 9 minus CF. And we had 10,923.3 divide 9 minus RCF is 1,095.12. So 1,095.12 po ito. Hindi ko ma-edit. And we had 1,213.7 minus 1,085.12, and we had 118.58. Ito po guys, 1,095.12 po ito. And we have our A times BECs, from our previous table, which 15.3 squared plus 30.9 squared plus 15.2 squared plus 27.0 squared plus 16.6 squared and 35.4 squared over our replications, which is 3 minus our CF minus AECs and BECs, and we had 3,677.66 divide 3 minus 1,095.12 minus 8.09 minus 118.58, and we had 1,225.89 minus 1,095.12 minus 8.09 minus 118.58, and we had 4.1. In our AECs equals to TECs minus RECs minus AECs minus BECs minus 8 times BECs, and we had 132.12 minus 0.09 minus 8.09 minus 118.58 and 4.1, and we had 1.26. So this tables is our ANOVA for Rcbd factorial. Is B for DF, SSS, MS, and FC, and our tabulation F. Replication 1, our DF is 2, our SSS is 0.09, our MS is 0.45. And our planting distance 2, 8.09, 4.045, and our FC is 32.10, which is significant. Weeding frequency B times B1. So 118.58, 118.58, then 941.11, which is highly significant from our FC. And our A times B, our planting distance and reading frequency. With DF of 2, ACC is 4.10, with our MS 2.05, and we have our FC 16.27, which is highly significant from our tab F. And error is 10, our DF is with 1.26, and M is 0.126, with a total of our DF is 17 and our ACC is 132.12. Then our RCB is equals to 4.55%, which is highly significant our experiment. So we have C, we have our CB equals to square root of MSE over our grand mean times 100, and we had 0.26 squared and 0.26 square root of 0.26 over 7.8 times 100, and we had 0.355 over 7.8 times 100, and 0.045455 times 100 is equals to 4.55, and we have our CV is 4.55%. So that's all, and thank you. So those all of these data are examples on how we solve our experiment. And for your clarification, just uh, comments on our group chat to address your concern. That's all, and thank you.